Understanding the difference between artificial gravity and centrifugal force. 1. Artificial gravity. Artificial gravity refers to the creation of gravitational forces similar to those experienced on Earth's surface for astronauts or objects in space habitats or spacecraft. This concept is crucial for long-duration space missions or colonies where prolonged exposure to microgravity can have detrimental effects on human health. Methods for generating artificial gravity include rotating spacecraft or habitats to simulate gravity through centrifugal force. 2. Centrifugal force. Centrifugal force is a fictitious force perceived by an observer in a rotating frame of reference. When an object or person rotates around a central axis, centrifugal force acts outward from the axis of rotation. It is a result of inertia and the tendency of objects to move in straight lines unless acted upon by external forces. In rotating systems, such as a spinning spacecraft or a centrifuge, centrifugal force creates a sensation of gravity by pushing objects outward against the walls or floor. 3. Mechanism of generation. Artificial gravity relies on centrifugal force generated by rotation. By rotating a spacecraft or a habitat, centrifugal force acts radially outward from the center of rotation, creating a force similar to gravity. The magnitude of artificial gravity depends on the radius of rotation and the rate of rotation, angular velocity. Design considerations ensure that rotational speeds provide comfortable levels of artificial gravity without causing motion sickness or discomfort to occupants. 4. Applications in space exploration. Artificial gravity concepts are essential for future space missions beyond Earth's orbit, such as lunar bases, Mars missions, and long-duration space habitats. Maintaining physiological health and preventing muscle atrophy and bone loss in astronauts during extended space travel are primary goals for implementing artificial gravity solutions. 5. Physics of centrifugal force. Centrifugal force is a consequence of Newton's laws of motion and arises when an object moves along a curved path. It is directly proportional to the object's mass and the square of its rotational speed, and inversely proportional to the radius of rotation. Centrifugal force is experienced in various everyday situations, such as when driving around a curve or riding a merry-go-round. 6. Difference in perception. Artificial gravity creates a consistent gravitational environment akin to Earth's gravity, allowing objects or individuals inside a rotating structure to experience uniform gravitational forces. In contrast, centrifugal force is a perceived force that results from rotational motion and varies depending on the distance from the axis of rotation and the rate of rotation. 7. Engineering challenges. Implementing artificial gravity in space missions involves significant engineering challenges, including structural design considerations, power requirements for rotation, and mitigating potential issues such as vibrations and motion sickness induced by rotational acceleration. Advances in spacecraft design and materials science are crucial for developing practical solutions for generating artificial gravity. 8. Future prospects and research. Research continues into optimizing artificial gravity systems for space habitats and exploring alternative methods for creating gravitational environments in space, such as electromagnetic or gravitational manipulation technologies. Understanding the physiological effects of artificial gravity on humans and biological systems remains a focus for future space exploration and habitation initiatives.